Hey guys, welcome back to the channel. Today I'll be showing you guys how to optimize and design a trading strategy that involves setting a particular entry and having a multi-exit option. So for example, in this tutorial, we're going to design an algorithm for stocks that generates short signals. And for the exits, we will have three options. So we will either get stopped out, hold a max number of days, or exit at the very first profitable close. So I'm not going to focus too much on the strategy here. What I want to focus on is the design, as I'm sure most would like to test their own strategies. So I'll go over an example with you guys on how to implement a backtest. To start off with, these are some of the packages we're going to require. And for this optimization, I'm going to go ahead and backtest Apple. So we're going to get some data from Yahoo Finance, and we're going to store it in this variable called all. So I'm going to run these three lines. All right, so for the backtest, I built this function where we will enter a backtest end date. As you see in this following line, I want my backtest to end at the end of 2020. If you're looking for a specific date, you could just enter it for BT end. So say you want the end of June 2020, you would just insert 06. If you want to get more specific and enter the date, you would just go ahead and add the date in the same format. So we'll go ahead and leave it how it was. Now for these extra parameters, which involve the strategy, I wanted to focus on a stock that's rising and see if there was any short opportunities or reversals, in which I will compare different bars. So all these parameters involve comparing bars, and the numbers you see are the look back days. And I'll go over that once I open up this function, but I just wanted to give a brief overview on what the parameters are. Now for the stop loss, since I'm shorting, I will get stopped if the price rises above the highest price in the previous 5 days. So a roll max N is just the number of days we should look back to compare the latest price to the highest price. And lastly, we have max hold days, which is the max number of days I'm willing to hold this stock. So again, we're going to end up optimizing for these look back days. So if we open up this function here, we're going to start off by assigning our stock data into temp, and this next line we're just subsetting so that we have a training data set and a validation set. So here I'm just going to subset up to the point the user enters for the backtest. So for my range, I'm stopping at the end of 2020. So we're only optimizing up to that point. Now we need to generate signals for our strategy. So depending on your strategy, we're going to assign a new column for the entry signal, and we're going to set that equal to NA. And then we're going to go ahead and run a loop to generate signals. And for this strategy, the furthest I'll look back is 10 days. So that's why I started off this for loop at 10. If you want to implement something that requires a larger look back period, just make sure you modify this 10 to accommodate for your backtest. All right, so for each row, I'll be comparing different bars. So this will generate a short signal if the close is greater than the high and the open is less than or equal to the low at a different bar. And also the open is less than or equal to the high of a different bar. So it's going to compare different bars and trigger a short signal if all of these are met. Otherwise, it'll just return a 0. And all of these look back days will get passed in as arguments for this optimization. So depending on your strategy, you would enter your entry signals here in this block. Now, after we generate the entry signals, we need to add the stop price as a new column. So here in line 28, I'm going to go ahead and add the rolling max of the high, and K is just the number of look back days, so that will get passed in. If you would rather use a percentage for a stop loss, you would need to make sure that this column has the stop prices instead of the percentages, as later on in the script we will compare this stop price to the current or latest price and see whether or not we got stopped. So again, just make sure that this column here has the stop prices and not the percentages. All right, once we have that, we can go ahead and extract the signals. So since I'm short, I'm only going to extract cases where our entry signal is equal to -1. So I'll go ahead and extract those locations or those bars. Once we have the locations on where we have signals, we're going to use lapply and pass those in, and we're going to apply this function. And we're going to start off by subsetting the range starting on where we generated our short signal or our entry and adding X number of hold days. So max hold days, if you remember, was one of the arguments. This will get passed in. So we're just going to subset our trading window basically. If the data is within the range, we're going to do the following. It could be that we are currently in a short position and it will not be able to calculate an exit since we're currently currently in that position. So only if the data is within the range, we're going to do the following. And again, we're just going to subset the trade range starting on the date or the bar where the short signal occurred up to the number of days we should hold. So that'll be our trade range. We're going to extract our entry price or our short price, which will be the very first close in that data. Now for each of these trade ranges, we need to look for what happened first. Either we got stopped out, we closed our position at the very first profitable close, or if none of those two happened, then we held for the max number of hold days. So we start off by locating the first profitable close if possible. So here I'm just looking for at what bar after our entry was this trade profitable, and I'm going to save that into iLock1. It could be the case where none of the bars in our trade range are profitable, so this will return an NA. So here in the next line, if that's the case, then we're going to set iLock1 to 10,000, and this is just a sentinel. Since we're looking which happened first, I set this to a large number because essentially we're just looking for which location is the minimum. So if we got an NA, I'm going to set it to 10,000, otherwise just return iLock1. Now for the cases where we got stopped, I'm comparing whether the close is greater than or equal to our stop price, and if that generates an NA, we're going to set iLock2 to 10,000, otherwise just return iLock2. Now once we have our locations for the first profitable close or whether we got stopped, we can now compare these. So here for the exit trades, if iLock1 is equal to iLock2, meaning that both of these were NAs, then our exit will be the last price within our trade range. So as you see, I have set our exit price to the close on the very last bar in our trade range. And I'm also going to add a column called exit where we can take a look and see how many times we got stopped, how many times we exited on the last day, and how many times we exited at the first profitable close. So if that's the case, we have essentially found our exit price and the type of exit. Otherwise, we need to compare iLock1 with iLock2. So if they don't equal each other, we need to find which one is the minimum. So if iLock1 is less than iLock2, that means we exited at the first profitable close, and I'll assign the exit price and the exit date. Otherwise, if we got stopped, meaning that iLock2 is less than iLock1, we assign our exit price and our exit type will be stopped. And for each of these, I also assign the exit date, so we can later compare and generate an XCS object if necessary. And this will be it for our exits. If the close is outside of our data set, that means that the trade is in process. So if that's the case, our trade range will be stopped at the maximum number of rows in our data set. And here we just manually need to assign our entry price or our short price. And since this is a trade in progress, our exit price is NA, our exit date is NA. And for the exit type, we're just gonna assign that to current position. After that set, we need to create a trade log where we just combine everything, and essentially we get a summary of our entry date, our exit date, our short price or our entry price, our exit price, the number of points that we generated in this trade, the percentage return, and the exit type. And then finally, for each of these instances, we're going to return our trade log. So if we minimize this, after it iterates through all of our signals, we're going to combine everything using our bind list. So all of our trades will get row binded into one single data frame. And then finally, just return our trade log, which will contain all the trades. All right, so if we minimize this function, I'm going to go ahead and run it. As an example, I'm going to generate a trade log using the following parameters. And we're going to go ahead and take a look at this trade log. So since 1990, we have approximately 522 different signals generated. So again, we see our entry date, our exit date, our short price or our entry price, our exit price, the number of points this trade generated, and the percentage return. And lastly, we have a column for the exit type or class. So for this particular row, we exited at the first profitable close. So this will be the data frame with all of our trades that we can later extract information from. But for now, I just want to use this trade log to extract the percentage returns and send it through an optimization. So let's go ahead and close this out. Since I backtested until 2020, there could be some pending trades. So I'm just going to go ahead and exclude those so that we can generate an XCS object. So I'll go ahead and convert my returns into an XCS object, and we're going to go ahead and plot the returns. So as it stands, it looks like it was performing well up until approximately 2004, and then afterwards it just began to tank. So now we're going to send this through an optimization and hopefully find some parameters and look back periods that will yield a greater result. So let's go back to our script. Alright, so for the optimization, I'll be using DEoptim, and we need to create an optimization function in which it will seek to generate the greatest Sharpe ratio. So by passing in n, which will have or contain all the lookback periods for each of these arguments, I'm going to extract the Sharpe ratio, and notice I wrap this in this try function. So if any of these arguments create an error, then we're going to set our Sharpe ratio equal to -1. Otherwise, we're going to exclude all of our pending trades, return this as an XDS object, and return the Sharpe ratio. So I set this equal to -1 since DEoptim seeks to minimize. So if the Sharpe ratio is -1, I'm returning the inverse. Again, since we're trying to find the minimum, then essentially all the errors will get excluded. If that makes any sense, if any part was confusing, just leave a comment and I'll try to explain it better. But for now, I'm just going to go ahead and run this function. I also need to create a function that rounds all the lookback periods to whole numbers. We can't have fractional lookback periods. So in this function, I'm just going to round everything to whole numbers, and we're going to use that function in our optimization as well. Now for each of the arguments, we need to pass in our lower and upper bounds, and we have 8 arguments. So your lower and upper should be the same length. So for arguments 1 through 6, which we are just comparing different bars, my lower bounds will be 0 and my upper bounds will be 10. For our rolling max n and the max number of whole days, my minimum will be 1 day and the upper will be 14 and 5. And again, these are just look back days. So I'll go ahead and run these as well. Now we have 2 options using DEoptim. Either we can run it in parallel or without, and depending on which one you choose, there are different requirements, but I have set these up in case you want to use either. But for either case, you will find some overlap. So the first thing we need to insert is our optimization function. We also need our lower and upper bounds. For a control list, we need to enter the maximum number of iterations we want this to run. And if your strategy involves something that's a little bit more complex, I recommend you use an iteration greater than 100. And we also need to insert our fnmap function, where we need to round or specify the number of digits to round to. And if you want to run this in parallel, we need to insert a couple more things. We need to specify parallel type, which is equal to 1. Our variables that we need to use, so our stock data and our strat backtest function. We also need to specify the packages involved, which will be these 3 packages. And I'm setting trace equal to true so that we get a printout out in the console. So I'm not going to run DEoptim because I have already saved these 10 iterations as an RDS file. So I'm just going to read those in. But just know that if you run these in parallel, it's much faster than running it without. And at each iteration out in the console, you'll see something similar to this, where the values here are the Sharpe ratio, since that's what we're trying to optimize for. And each of these values represents the arguments passed in, where in our case, these would be the lookback days for each of the arguments. So once it's done running, it'll get saved into this variable called R. So let's go ahead and read those in. Since I only ran it for 10 iterations, it's not fully optimized, but let's see what it came up with. And I'll go ahead and extract the best combinations and assign them to OP. Now I'm going to use the optimization results and pass them into the arguments. So that'll get saved into best. And again, I need to remove any pending trades at the end of 2020, convert this to an XDS object, and plot the results. Alright, according to the optimization, these were the results. So between 1990 and at the end of 2020, we have a few trades, doesn't trade that much, and we've generated a return of above 50%. It seems like there was only one negative return during the backtest of less than 1%. So now let's go ahead and apply the same look back days according to the optimization in our validation set. So let's go ahead and close this out. So in order to do that, we need to change or modify our function. So this function is essentially the same as strat_bt. The only thing I changed was I blocked out this line where we only subset our data. So that's the only thing I modified here. I'll go ahead and run this function. Get our out of sample returns according to the optimization. We remove any pending trades and convert this to an XDS object. And let's go ahead and plot the results. It looks like we just had one single trade after 2020, which was in the positive. So since I only ran this for 10 iterations, it did not find the best combination of lookback days that would yield the best Sharpe ratio in our training data set. So just make sure when you run this optimization, you increase the iterations. If you want to take a look at your trades and a breakdown, you could always take a look at your trade log. So for add a sample, just look at sub trade log 2. So we only have 14 different trades, and it looks like our add a sample returned 0.5% and it exited at the first profitable close. If you want to take a look at what lookback days to use, you could just run OP, and out in the console, you'll see the best combination according to the optimization, and each of these represents the numbers we should use for each of the arguments. So as an example, this very first number is the number we should use for our close and 1, and the last one, or par 8, which is 3, is the max number of hold days. So that's how you would interpret these results for the optimization. Well guys, this concludes the video. I didn't want to focus too much on the strategy, as I'm sure you guys will implement your own, but rather I wanted to focus on the design and how to optimize. Well guys, I'll go ahead and leave a link down in the description area to my Patreon where you can find the script. Please subscribe to the channel if you haven't done so already. Thank you so much for watching, and I'll see you guys in the next video.